All right, hello, ladies and gentlemen. We are back to chemical equations today, the why and how. And today we're going to be moving on to part two. But before we do that, let's just kind of take a little bit of a look at where we left off yesterday. So when we left off yesterday, we mentioned that a chemical equation is what represents what happens in a chemical reaction, and that we had watched the video, and I know there were some issues with that video. Hopefully you got a chance to watch it, but you saw zinc and hydrochloric acid reacting with one another, producing zinc chloride and hydrogen gas. And so we saw that right here we have the chemical equation using formulas and other symbols to represent what happened in that reaction. So today we are going to move on a little bit into part two about counting atoms, because before you can really correctly write a chemical equation or balance a chemical equation, which we will eventually be doing, you need to be able to correctly count the atoms in chemical formulas. You can't tell if the law of conservation of mass is being represented correctly by the equation unless you can tell exactly how many of each kind of atom there is there. So we're going to take a look at a few basics to see how we go about doing that. All right, so first thing we need to know, what is a chemical formula? All right, well, a chemical formula, it represents a molecule. Remember when we talked about chemical bonding, we talked about molecules, and how a molecule is atoms that are bonded together, typically by covalent bonds. And that molecule uses symbols to show the number of atoms of each kind of element. So here's a few examples. We have H2O, we're all familiar with. That is water, 2 hydrogens, 1 oxygen. We have NaHCO3, that would be sodium, hydrogen, carbon, oxygen. We know that this CO is not cobalt because both of these are capital letters, remember? And so that's carbon and oxygen 3. And that is the chemical formula for baking soda. And then over here we have NaCl. Hopefully we're all familiar with that by this time. Sodium and chlorine, making sodium chloride or table salt. So those are examples of chemical formulas. So, what are the parts of a chemical formula? Well, there are 4 different parts we're going to talk about. The first one is the chemical symbol. And the chemical symbol is the 1 or 2 letter symbol, like we find on the periodic table, that represents an element. So the first letter of an element symbol is always a capital letter. We've talked about this. The second letter is always lowercase. So we have a couple of examples here. Capital H for hydrogen, Ca for calcium, capital C lowercase a. Again, this is why you want to be familiar with as many of the element symbols on the periodic table as possible, so that you can recognize what these different elements are when you see them. You can refer to a periodic table, but if you become familiar with some of them, that becomes helpful. All right, the second part of a chemical formula is the subscript. Not all chemical formulas have subscripts. NaCl does not have a subscript. However, CaCl2 does have a subscript. So the subscript is what tells you the number of atoms of a particular element and only refers to the element that it is behind. So the element that it comes right before the subscript is the only element that is affected by the subscript, so to speak. Okay. If there's no subscript, then that means that there's only one atom of that element. I mean, the letters wouldn't be there if the element wasn't there. A lot of times in math, we don't put a 1 in front of a lot of things because multiplying by 1 is the same thing as having that number there. So it's like multiplying by 1. So the 2 right here is the subscript, and it goes with the Cl, okay, with the Cl. So we have CaCl2. That means we have 1 atom of calcium, because there's no subscript after it. And we have 2 atoms of chlorine because of the subscript 2 here, which goes with the Cl, with the chlorine. All right, the next one is coefficient. Coefficient. It's another number. Looks a little different, but the coefficient tells us how many molecules there are. Okay, if you had H2O and there was a big number 3 in front of the H2O, then that means that there are 3 H2O molecules. So it's placed in front of the chemical formula. It's significantly larger than subscripts. And then you basically multiply the coefficient, that big number in the front, by the subscript, any small numbers that may be in there, if there are any, to find out the number of atoms for each element. So if you look here, here's our coefficient of 4. We have 4 CO2. So this is carbon. This is oxygen. Again, we know it's not cobalt because they're both capital letters. So we have CO2. This is carbon dioxide, in case you were wondering. Didn't recognize it. We have 4 carbon dioxide molecules here. So if we have 4 carbon dioxide molecules, how many carbon atoms do we have? Well, we have 4. Okay, it's actually a little bit like, and I think I'm going to do this here. So it's almost as if there are imaginary parentheses around your molecule. Okay, there's your molecule. And then this 4, and this is going to be exciting, folks. Remember that distributive property you talked about in math for a few years, and after a year or so you started tuning it out? Well, this is one place where it comes in handy. So we're going to basically distribute this 4 to everything inside the parentheses. So that means there are 4 carbons. There's no subscript there, so that's like an imaginary subscript of 1. So 4 times 1, so 4 carbons. And then in every molecule of carbon dioxide, there are 2 oxygens, but we have 4 molecules. So we have 2 oxygens 4 times, which is 8 atoms of oxygen. Okay, so that is the coefficient. That is the large number that is in front of molecules. Again, not every formula has that, but many of them do. Okay, the next one is parentheses. Again, not every chemical formula has parentheses, but some of them do. So with the parentheses, you're going to multiply the subscript that is outside the parentheses by the number of atoms that are inside the parentheses. So let's take a look here. Pb, we know this is lead. We have N, which is nitrogen. We have O, which is oxygen. Okay, so we have a set of parentheses here that are not imaginary ones like before. These are actual parentheses. All right, so let me get rid of those copied over parentheses there. So we've got parentheses there. Now these parentheses do not in any way affect the lead. Okay, the lead is not affected at all right here. So that means there is just 1 atom of lead. 1 atom of lead. There are no numbers there that are affecting it. The letters are there, so we know we have some. The NO3 is in parentheses, and it's telling us that there are 2 of those NO3s. So 2 of these NO3s are somehow combined with or attached to the lead. So how many nitrogens do we have? Well, if we didn't have this little 2 out here, we would just have 1 nitrogen, but there's a 2 out here. So again, we're going to use the distributive property to, well, we're going to distribute the 2 to everything inside the parentheses. So we end up with 2 nitrogens, and then we have O3, and we have that 2 times, so we have 3 oxygens, and we have that 2 times, which gives us a total of 6 atoms of oxygen. Okay, I know it's the collision of math and science. I am so sorry, but I personally just get excited by this because I love to see how God just incorporates all these different things. All right, so we're going to do a little bit of practice here. Here's a formula. We have 3BaCl2. Ba, you might recall, is barium. So here's our Ba. Here's our Cl, which of course is chlorine. So this 3, remember, there are kind of like imaginary parentheses around here. So this 3 is going to get distributed to everything inside, or the 3 is going to get distributed to everything inside the parentheses. So how many barium do we have? There's no subscript over here. So we have a total of 3 barium. There's 1 barium here, and we have it 3 times. Okay, and then with the chlorine, here we have, see if I can get it over here, we have 2 chlorines, but we have it 3 times, so we have a total of 6 chlorines. 3 times 2 is 6. All right, let's take a look at another one, another example. Here we've got some parentheses. All right, here we go. We have NaCO3 2. NaCO3 2. So Na, we know, is sodium. C, carbon. O, oxygen. Let's start with sodium. Start with the sodium. There is no coefficient out in front. So we just have 1 molecule of this kind of odd NaCO3 2. I'm going to erase my little box there. So there's no coefficient. There's no subscript after the Na. So we have to assume that there is just 1 Na. Now this 2 over here, this 2 doesn't affect the Na in any way because that is outside the parentheses, and so it goes with things that are inside the parentheses. It goes with whatever comes immediately before it. So there is 1 sodium atom. Carbon is inside the parentheses, so this 2 gets distributed to what's inside the parentheses, which means there are 2 carbon atoms. And then there was O3, but we have that 2 times. So that means we have 6 oxygen atoms. All right, let's try one more. This one also has parentheses. So here we have Al, aluminum, S, sulfur, O, oxygen. Okay, how many aluminum do we have? Well, you can see that we do not have any coefficients right here in front of the molecule. So we have just 1 molecule here, but there is a subscript after the Al, after the aluminum, which tells us that there are, because it's a subscript of 2, there are 2 atoms of aluminum. Now we've got parentheses, and we have a 3 outside the parentheses that we are going to distribute to what is inside. The sulfur doesn't have any subscript. It just has the subscript that's outside. And so that means that there are 3 sulfurs. The oxygen does have a subscript of 4, which is 4 oxygens, but we're going to have those 4 oxygens 3 times, which gives us a total of 12 oxygen atoms. All right, ladies and gentlemen, you are going to be working on some more practice of counting atoms, because this is a really critical skill to be able to go on to our next step of what we will be doing in just a couple days. So please make sure that you upload your notes. That is what is due today, from your notes from this PowerPoint. Print out the assignment, get to work on that. It is not due today. Bring it with you to your live class tomorrow, all completed, so that we can go over it, and we will not only go over it, but work through any issues and things that you may have had with it. All right, ladies and gents, you have a fabulous Cinco de Mayo.